Alright, so we want to do revision of linear equations, and I get to sit outside on this beautiful morning, and so you might hear some cars going past or some birds tweeting, don't worry about that. Basically what we want to do is just run through how we solve equations by inspection, or using a more formal method, or when we've got brackets, or fractions, or quadratic equations. And I'll just do a couple of questions in each of those. The idea behind the video is that you can stop it, pause it, rewind it, try the question yourself, or do the question with me, whatever way works for you. Okay, so just very quickly to kick off, in a linear equation, we have a left-hand side, and that is equal to the right-hand side. And every equation, the left-hand side must be equal to the right-hand side. And we've gone over this a couple of times, that when we have an equal sign, it means is the same as. So if we want to solve it by inspection, it means we can look at it and we can find the value of x. And so if the left-hand side is equal to the right-hand side, in each of these, we can ask ourselves what value of x would satisfy this equation, make it true. So we ask ourselves what value of x makes the left-hand side equal to the right-hand side. 2 times what number is going to be equal to 6? Very easy, x is equal to 3. Or if we looked at the fraction here, what number divided by 4 would give me 3? The answer obviously is 12, because 12 divided by 4 is 3. And even in a question like number 3, 3x plus 5 is equal to 14. Well, 3 times what number, add another 5, will be the same as 14. And 3 times 3 is 9, and 9 plus 5 is 14. So you can solve an equation very easily by looking at it and going, what value of x makes the left-hand side equal to the right-hand side? If we wanted to use a more formal approach, we can use the idea of what we do to one side, we do to the other side. So you can multiply and divide by the same number, or you can add and subtract both sides by the same number. We always start by taking away the number that has no variable with it, and we bring it over to the other side. Formally what we're doing is subtracting 8 from this side, and what we do to one side, we do to the other side. Another way of thinking about this is 8 comes over the bridge and becomes minus 8. So we've got 3x is equal to 17 minus 8. 17 minus 8 is 9. And now we want to divide both sides by the number that's left. And the number that's left is 3. If I divided this side by 3, I'd have x left alone. But what you do to one side, you do to the other side. X is equal to 3. Number 2 is a bit more tricky, but we use the same principle. 1 comes over, and it's going to leave me with positive 1. Comes over the bridge, becomes 3 plus 1. I'm not going to write it out. It's 4. Not a very nice 4. There's 4. Now we've got 2 times x. We're also dividing by 3. You start by taking away the fraction. Whoopsie, what's that? Take away the fraction. If I multiply by 3, that would cancel, and what I do to one side, I do to the other side. So I have 4 times 3. And 4 times 3 is 12. And so I've got 2x is equal to 12. I need to divide both sides by 2 to get rid of the 2 in front of x over here. That divided by 2 leaves me x. And what I do to one side, I do to the other side. 12 divided by 2 is 6. So that's a more formal approach. Further, we can work with brackets. Very easy. Multiply out the brackets all the time. And what's right next to the bracket is multiplied by what's inside the bracket. So starting on the left-hand side, 5 times 2x is 10x. And 5 times negative 3, a positive times a negative is a negative. 5 times 3 is 15. This one over here has 3 sitting on this side, but it's still what is right next to the bracket. So what's right next to the bracket? Multiplied by each term inside the bracket. 3 times 2x is 6x. And 3 times negative 9, again a positive times a negative is a negative. 3 times 9 is 27. On this side we keep our 10x on the left hand side. We bring 6x over and becomes negative 6x. Don't forget to change the sign. We've got negative 27 on this side, and negative 15 comes over, becomes positive 15. So on the left hand side we've got 10x minus 6x is 4x, and negative 27 plus 15 is negative 12. then divide both sides by 4, and this divided by 4 leaves me x, and a positive divided by a negative is a negative. 12 divided by 4 is negative 3. Good idea here is stop the video and try the next one yourself, and then I'll work it through with you. Or you can just watch me do it. It's right next to the bracket, multiplied by each term inside the bracket. 3 times 2 gives me 6x, and 2 times 1 is 2. So the idea is once you get to this point over here, then we've got a basic equation. We keep 6x on this left-hand side, negative 4x comes over and becomes positive 4x. 7 stays on the right-hand side, and 2 comes over and becomes negative 2. And 6 and 4 is 10x. And 7 minus 2 is 5. Divide both sides by 10, and we're left with 5 over 10. I wanted to show you this one because always look at your answer and go, can I simplify that any further? And you can, to 1 over 2. And that will be your final answer. So just make a little note here that you want to always simplify your fractions. I know that when we get equations with fractions, you kind of freak out. Don't. All we're going to do is eliminate these denominators. And the way we do that is we multiply through by the lowest common denominator. So on the side right, our lowest common denominator between 2 and 3 is 6. It is the lowest number that both of them can multiply into. And so we multiply each term. There's my a over 2, I multiply it by 6, and 6 over 1 multiplied by a over 3. And don't forget this 1 over here is actually 1 over 1. If I wrote it as a fraction, I'd write it as 1 over 1, and that must also be multiplied by 6. So when I get here, 2 goes into here once, into there 3 times. So 3 times a is 3a. 3 goes into here once, into here twice, and that's going to leave me 2a. Because 2 times a is 2a, and 6 times 1 is 6. And again, I've got a basic fraction. 3 plus 2 is 5a's. It's equal to 6. We divide both sides. I'm just going to push up here, I've run out of space. We divide both sides by 5. That leaves me 6 over 5. And just simplify your fraction. Saying 5 goes into 6 one time, and then 1 over 5. Question 2 is one I pulled out because this fraction line over here and this line over here means this is one term. When you're multiplying through, you've got to keep it in brackets. Otherwise, you're not going to multiply each term by the lowest common denominator. So, just a reminder, that's 1 over 1. The lowest common denominator in this question is 4 because both 2 and 4 can go into 4. So when I multiply the first term, I keep 2x minus 3 in brackets. And when I multiply, what have I just done? How do I do this? Just undo here quickly. Minus 4 over 1, multiplied again in brackets, 3x plus 1 over 4. And don't forget that 1 also needs to be multiplied by 4 over 1. So 2 goes into here once, into here 2 times. That leaves me 2x minus 3. Keep in mind this is a negative. Don't leave it out. Negative. 4 goes into here once, into here once. It's negative 1. 3x plus 1 is equal to 4 times 1 is 4. Now I've multiplied through and I've eliminated my denominator. Now I've got an equation that has brackets, everything next to the bracket, multiplied by what's inside the bracket, a positive times a negative, don't forget, negative 6. And the reason I kept this section here, both of these, in my brackets, the reason we want to do that is because everything that's next to the bracket must be multiplied through. So now I've got negative 1, let's make that so it doesn't look like an equal sign, it becomes negative 3x because negative 1 times 3x is negative 3x, and a negative times positive is a negative. 1 times 1 is 1, is equal to 4. Group your like terms. 4x minus 3x is x, minus 6 over here, minus 1 is minus 7, is equal to 4. Let's just shift this up here so I can carry on working. Negative 7 comes over and becomes positive 7. X is equal to 11. That's not so tough. You guys can do that. Alright, the last type we want to do as we finish off is a quadratic equation. A quadratic equation is going to be in the form of x squared. Notice if I took this section here and I multiplied it through, I'd get 2x squared minus 6x is equal to 0. And that would need to be factorized. And to factorize 2x squared minus 6x, we take out a common factor of x, leaves me 2x minus 6. So in question number 1, this has already been factorized for us. So it's factorized, that should have actually come first, and it's set to 0. So this is already factorized, it's set to 0, so we can very easily go x is equal to 0, or 2x minus 6 is equal to 0. Because it's factorized and set to 0, I take each term and set it to 0. X is equal to 0 stays the same. This 2x must be solved, so minus 6 comes over and becomes positive 6. And both sides divided by 2 leaves me 3. And if I plug in each of these values, x is equal to 0 or x is equal to 3, into my equation, I will get left-hand side equal to right-hand side. So both those values, x is equal to 0 and x is equal to 3, satisfy the equation. In question 2, remember we said it's got to be set to 0, and obviously it's not set to 0, and it's got to be factorized. Well, let's set it to 0 first. So 49 comes over and becomes minus 49 is equal to 0. So I've got an x squared, making it a quadratic, and I've got it set to 0. Next step is to factorize here, and this is the difference of squares. So we get x minus 7 and x plus 7 is equal to 0. Right, x minus 7 is equal to 0, or, don't leave out the word or x plus 7 is equal to 0. Solve the equation, minus 7 comes over, become positive 7, and 7 comes over, becomes negative 7. Again, both of these values for x, if they're plugged into the equation, will make it true. So one last one I want to show you. We've got m squared, so whether it's x squared or m squared, it's still a quadratic. And this quadratic hasn't been set to 0, so we're going to set it to 0 first. M squared plus 3m, bring 4 over, becomes, whoopsie, that's not nice. Let's write this properly. M minus 4. Minus 4 comes over because plus 4 came over, became minus 4. And this is a trinomial. So what are the factors of 4 that will subtract to give me 3? Well, factors of 4 that subtract to give me 3 are 4 and 1. So we're going to have m and 4, and we're going to have m and 1. I've just got to decide on the signs now. The signs are different. Remember, negative tells me they're different. The sign of the bigger one is going to be positive. Don't forget how to factorize a trinomial. That's really important. Last steps, m plus 4 is equal to 0, or m minus 1 is equal to 0. Solve the equation. Positive 4 comes over and becomes negative 4, and negative 1 comes over, becomes positive 1. And again, both values of m will solve the equation, making the left-hand side equal to the right-hand side. And that is equations. Hope you figured something out you didn't know. If you want, go back, go through the questions yourself, and then see if you get the right answer. Good luck for Friday's test.